All right, Shay. So let's start with the question you had yesterday, which I had a minute to kind of look over a little bit more carefully. And that was number 16 on page 54. And that was the one where it said each of the functions f of x equals x cubed minus 27x plus 54, and g of x equals x cubed minus 27x minus 54 has one zero of multiplicity 2, and then a different zero. So they wanted you to only use that information to determine which values of b for which h of x equals x cubed minus 27 plus b has each number of zeros. And the first one was going to be 3 different zeros. So we were actually overthinking it, thinking that you'd have to go through all of the different possibilities. So in here, we were both considering all of the different zeros that could make that true. And that's just going to take forever. What the textbook really wants you to focus on is just the fact that you've got the f of x and the g of x to go by. So if I look at x cubed minus 27x plus 54, what I'm going to be doing is just doing a quick sketch, and you can either graph it if you want on your graphing calculator, or if you really remember how to do this without, you know that it's got 1 0 with multiplicity 2, and then we've got another 0 after that. So it just touches the x-axis at the point that corresponds to the 0 of multiplicity 2, and it's got a y-intercept of positive 54. This is f of x, by the way. And then we've got g of x over here, my lovely drawings, and it's going to be basically moved down. So we've still got our 0 of multiplicity 2, but we've got now that it's underneath the x-axis for most of its life here, because we've got a y-intercept of negative 54, and that one's g of x. So if we look at that, the graph of f of x has y-intercept 54, and then g of x has negative 54. So for the graph of h of x, which was the one with the value of b in it, to have 3 different zeros, it must be somewhere in between this and this, essentially. So we could have all of these different points all the way up until it meets the other graph, where it could have actually 3 different zeros, because if I look at it, this one's moved down, this one's moved down, this one's moved down. There's our 3 different zeros. So what I would do is say that b is going to be bounded by positive 54 and negative 54, and it could essentially be all real numbers in between there. Alrighty, so I think that pretty much takes care of that. And then 1 0 of multiplicity 1 and no other zeros, so that's for b. I'm going to leave that one up to you, and it's basically the same idea as this one. Just take a look at these two graphs and how would you have to move them up or down in order to get a 0 of multiplicity 1 and no other zeros. All right, so sometimes you overthink things, which is okay, as long as Ms. Bryden goes home and then realizes that, yes, that's the case. Okay, so for 1.5, it's modeling and solving problems with polynomial functions. This one isn't too much new material. Basically, the whole idea here is that you're now writing new polynomial functions for certain situations that you can model, and then you're going to use your graphing calculator to go ahead and examine them, looking at maximums and minimums and things like that. The first one we can start with is example 1 on page 58, and it says using the graph of a cubic function to solve a problem. So it says a piece of sheet metal 25 centimeters long and 18 centimeters wide is used to make a box with no lid. Equal squares of side length x centimeters are cut from the corners and the sides are folded up. So here's one of those lovely little diagram problems. We've got 18 along here, top to bottom. We've got 25 along here, left to right. And then what they've done is they've actually chopped out a little border here of size x. So that would mean this is x.
Yeah.
This is x. Oh, I might get kicked out of here, Shay. I'll finish this in class. It's okay. Don't worry about it. It's okay. I'll just stop it.